morning to all. So in the applied physics subject, so we are going to discuss unit number 1, so quantum mechanics. In that quantum mechanics, lecture number 1 is introduction to quantum mechanics and black body radiation. So first of all, we have to know what is meant by mechanics. Mechanics is the branch of physics which deals with motion of an object. Then if you consider size of an object, the object will be divided into two categories. One is a big object, usually called as a macro object, and second one is small object, which is micro object. What is meant by this macro and micro objects? The macro object is nothing but the size of the object we can able to see with our naked eye will be called as macro object. And the object whose size is we can't able to see with our naked eye, then such a object will be called as micro object. To study the motion of such a micro object, we have to use quantum mechanics, and to study the motion of a macro object, big object, we have to use classical mechanics. That is the use of two types of mechanics. And if we consider the classical mechanics, already mentioned, it deals with motion of macro object. And in case of classical mechanics, we are going to get exact and accurate results because the initial state of the particle is established with sufficient accuracy. Therefore, by knowing the initial state accurately, then by using any one of 4 Newton's equations of motions, we can able to get the exact or accurate results. And we know the 4 Newton's equations of motions are S equals to ut plus half at square, b square minus u square equals to 2as, b equals to u plus at, and Sn equals to u plus a into n minus half. By using any one of those 4 equations, we can able to get the exact results which is related to the motion of a big body, macro body. Then such a mechanics is also called as Newtonian mechanics. Therefore, Newtonian mechanics or classical mechanics, both are same. And in case of classical mechanics, it is based on Maxwell's electromagnetic wave theory, according to which any amount of energy may be emitted or absorbed from a body is in the form of continuous manner. And already mentioned, the future state can be predicted with certainty because the initial state is established with sufficient accuracy. Then coming to our present topic, quantum mechanics, it deals with motion of micro object. Therefore, it deals with the problems which are related to the motion of microscopic world. And in case of quantum mechanics, we have to use only one wave equation to solve the problems which are related to the motion. That is Schrodinger's wave equation. Then it will be called as basic principle in quantum mechanics. That means whatever the problem which deals with motion of micro object, we have to use only Schrodinger's wave equation. And here we can't able to predict the motion of such a microparticle exactly along which direction it is going to move. That's why quantum mechanics deals with probabilities or uncertainties. Here we are going to get exact results. So here we are going to get the results in the form of probabilities or uncertainties. And up to certain extent in quantum mechanics, we are going to use Heisenberg uncertainty principle and de Broglie concept of dual nature of matter. And in case of quantum mechanics, it is almost based on Planck's quantum theory, according to which only discrete values of energies are permitted to emit or absorb. So already mentioned, very important point is it gives probabilities or uncertainties of finding the particle at various locations in space because initial state is not established with sufficient accuracy. And the next topic is black body radiation. To understand the concept of black body radiation, we have to use only quantum mechanics. So classical mechanics can't able to explain the spectrum of black body radiation. So what is meant by this black body radiation? First of all, you have to know what is meant by black body. So what is the definition of black body? A body that completely absorbs radiation of all wavelengths incident on it will be referred as a black body. When such a black body is heated, it emits radiations called as black body radiations. So if you heat such a black body, it emits radiations of all possible wavelengths or frequencies in the continuous manner, that is in the form of continuous spectrum. So radiations emitted by a body due to temperature is called as thermal radiations. And these thermal radiations are usually electromagnetic in nature, and its energy is smoothly distributed over all wavelengths. A thermal source is usually produces continuous spectrum of thermal radiations. To understand the concept of such a black body radiation, we have to depends upon only Planck's quantum theory. Then what is meant by this black body? So this is existing in the nature? No. Till now, there is no perfect black body which is available in the nature. But we can able to consider a certain type of arrangement which is very close approximation to a black body. So that is a cavity which is made out of a hollow container. So usually made up of with either iron or copper with a narrow opening in the form of neck, and it is painted all sides with the lamp black. Then it resembles to a close approximation to a black body. When such a body is heated, it gives radiations of all possible wavelengths in the form of spectrum. Then if you study the spectrum of such a black body radiation, which is there in this graph, at a given temperature, the intensity of the radiation is initially increases with increasing the wavelength and reaches to the peak value and then decreases. That means initially if you increase the temperature of a black body from the external means, that means from the surroundings. So the temperature of such a black body is gradually increases. As a result, it gives out the radiations. Those are also increases with increase of wavelength and reaches to a maximum value, and slowly it will decreases. The special distribution of radiation is a function of temperature alone. That means in order to get any radiation from the black body, we have to give temperature from the external means. In the presence of temperature, that means when you are heating the black body, then only it gives radiations of all possible wavelengths or frequencies in the form of a continuous spectrum. The portion of maximum peak shift towards lower wavelength with increasing the equilibrium temperature. So all these details you can able to see in this graph very clearly. Then classical mechanics could not explain the spectrum of black body radiation. So to understand such a spectrum of black body radiation, so how to depends upon Planck's quantum theory, so which gives very certain results related to the black body radiation. And if you consider the applications of black body radiation, so usually, so the important applications are, so give people the ability to calculate the temperatures of distant cosmic bodies. And the second important application is inspired new devices such as thermal vision and new types of thermometers, especially in COVID-19 situation. So the thermal scanners, which are made by using this type of technology known as thermometers. And this is the image of thermal scanning, which is made out of the applications of black body radiation. Thank you for listening.